This is question 6 on your January 2019 Mechanics 2 paper. It's an statics of rigid bodies. So, we have a plank, AB, is this one, is in equilibrium against a horizontal pole. I don't know what's very. This is the horizontal pole, and this is a horizontal surface that is rough. So it says the end of A of the plank rests on a rough horizontal ground. AB makes an angle theta with the ground, and the coefficient of friction between the plank and the ground is 1/4. So we have friction here, but we don't have friction here. Some questions you will have friction in both places. The plank is modeled as a uniform rod, so it means that I'm going to put the weight in the midpoint. The plank is modeled as a uniform rod at the pole as a rough horizontal peg. We have friction here as well. Is perpendicular to the vertical plane containing AP. So we have friction here and here. Given that cos of theta is given and the friction is limiting in both A and C, find the magnitude of the normal reaction on the plank at C. So first, we are going to represent all the forces that you have acting on the plank. So at A, you have normal reaction of the ground. So you have a vertical normal reaction, and I'm going to call it RA to distinguish from the reaction at C. And you have friction in this way, in this direction, because the plank is not moving, is in limiting equilibrium, and even if it's not moving, we know the force, the friction will go against the tendency of moving. So if this surface has no friction and is something like ice, the plank would slip down this way. So that means the friction goes against that. That's precisely what is stopping the plank of just slip down. So this friction here, and then at C, in the peg, I have a normal reaction perpendicular to the peg, which is in the radial direction, which is perpendicular to the plank as well. And again, friction will go in this direction because the plank will try to slip down. And I'm going to call this one. And then I have the weight, which is in the midpoint. So somewhere here, the weight says is 20 newtons. So I have 20 newtons. So these are my forces. This is the first thing that I have to do always with these questions. The mistake that usually you make in this type of questions where you have a plank or a bar or a rod that is held by a peg is to draw one more force here. You draw something like a weight. Even if you don't know what that weight is, you draw a weight there because you think there is some kind of weight in this peg, and I think it's because you get confused with questions where you have a particle and you are drawing the forces in the particle. This is not a particle, and I'm not drawing the forces anyway in the peg. I'm drawing the forces that are acting on my plank. So I'm like separating the plank from everything else, and I'm drawing the forces that are acting on the plank, not any other forces. So here, these and these are forces that are acting on the plank, and this is a force acting on the plank, and these two are forces acting on the plank. Even if they tell me anything about this peg, I won't have to draw it when I draw the forces of the plank. So this is the mistake that many times you do with these questions, is to draw a weight in this point. Yeah? Let me delete it. So what we're going to do is to find the magnitude of the normal reaction on the plank at C. We are going to think, if it's in equilibrium, remember two things are happening. One is the sum of forces in any direction is 0, and the sum of the moment about any point is 0. So if we take a minute to think if any of those would be more convenient, our question will be much faster and shorter. I need to find this one. So, and there are 1, 2, 3, 4 things that I don't know. If I take moments about, for example, A, I will get rid out of these forces in my equation because they don't produce moments because they pass through the point, and I will get rid out of this friction here because again pass the line of the force past the point. So the three forces that I don't know won't be producing moment, which could be ideal. So I'm going to take moments about A because I will have only one equation with one unknown. So it's perfect, super easy, and super quick. So for A, I'm going to take moments about A, and that will be 0. So the clockwise moment, which is this one, the moment of the weight, is going to be the same, the anti-clockwise moment, which is the moment of this force. So 20 times the line of the force, the distance to the line of the force. So this is the line of the force, and I need to find the distance from A perpendicular to the line of the force. So it's this side here. I know this is half, so this is the midpoint of the plank, so this is 2, and this is theta. So this length is going to be 2 cos of theta, and cos of theta is given, is this one. So I have the force is 20 newtons times the distance, which we say is 2 times cos of theta. This is going to be the same, the anti-clockwise moment, which is the one produced by RC. And RC times the distance between A perpendicular to RC is the 2.5 that they give us here. So it's RC 2.5. This is going to be RC times 2.5. Cos of theta is given, is 4/5, and if I do that, I have that RC is 12.8 newtons. So this is the first question that they ask. Next one, B, which is the longest, is 8 marks, is find the coefficient of friction between the plank and the pole. So they are asking the coefficient of friction here. They give us the other coefficient of friction, which is 1/4 between the floor and the plank. But now they're asking us this one. Remember, if the object, wherever it is in limiting equilibrium, that's what they say, and they say both of them are in limiting equilibrium. Let me find it. The friction is limiting at both A and C. That means that we can use the force that we know to find the friction. So the friction will be maximum, and it's going to be coefficient of friction times normal reaction, right? So we are going to use that for that formula. We have already taken moments. We can take moments again, but I think it makes more sense to work horizontally and vertically. So let's go to see what we have if we resolve forces vertically and horizontally. So I have two forces that are not in vertical and horizontal directions, that are the ones that are at C. So this one, friction, is going to be, this angle is the same that this angle, so it's theta. So I have friction times cos of theta, which is given, and the vertical one is going to be that friction sine of theta, and then I have one component for this one, which is RC. This angle is theta again, so that one will be cos of theta, and this one, so I have two components for each force, will be RC sine of theta. I don't know if you see all of the forces. I hope so. So you have, for this force, two components, for this force, two components. So let's go into solve. For example, we start with vertically, right? So for B, I'm going to resolve forces in vertical direction. So that means it's in equilibrium, so forces up will be forces down. Up, I have this one, and this one, and this one, and down, I have this one, right? So RA, RA plus RC cos of theta, RC cos of theta, plus the small red one, so this one, friction sine of theta, friction sine of theta is going to be the one pointing down, which is only 20 newtons, is the weight of the plank. Yeah, so I have one equation here. I know this value because I found it before. And I have cos and sine, so I know those values. But still I have RA and friction as unknowns. Let me do horizontally now. So forces pointing right will be the same that force pointing left. So I have a friction here, another friction here, but multiplied by cos, and one pointing left. So friction at A, so friction plus the other component of the friction, which is friction cos, so the other friction, cos of theta, is going to be the one pointing left, which is RC sine of theta. RC sine of theta. From here, I know this thing, but I don't know the friction, any of the friction. But I can find the friction here, because the friction here, no, I cannot find the friction here. Sorry, I can find the friction here if I find RA. So I can write that this friction at C is going to be mu RC. And the friction at A is, and this is the one that I need to find, and mu is the one given, friction is at A. So what we are going to do now is just to substitute everything that we know in our equations and see what is still missing. So first equation is going to be RA, I don't know, RA, plus RC, we found it in the section before, is 12.8. Cos of theta was 4/5, so times 4/5, plus friction. I'm going to use these two equations instead. So I need coefficient of friction RC, which is 12.8, and I'm just here. Yeah, I'm just substituting that. Sine of theta, we know if our cos of theta is 4/5, we know that our angle theta, this is adjacent, this is hypotenuse, so that means that this is going to be 3, 4, 5 to use Pythagoras. So sine of theta that we need now is 3/5. So I know this here is times by 3/5 equal, I'm here, 20. So I have two unknowns so far, RA and the coefficient of friction here. And the second equation is going to be friction, so I'm here, is going to be mu, which is given, is 1/4 times RA, so 1/4 times RA, plus the new friction, which is the coefficient of friction, times RC, which is 12.8, cos of theta here, which is 4/5, so times 4/5, is RC, which is 12.8, times sine of theta that we said it was 3/5. Right, so I have two equations now, and I have only two unknowns. So my new coefficient of friction and my RA. So I just solved my simultaneous equations. I can, for example, multiply this one all by 4 and then subtract to get rid out of RA, and I will find mu, the coefficient of friction at C. And this is going to be 0.63. It's just solving the simultaneous equations, right? So this is all with this question. This is what they ask. Always remember, when you have so many unknowns, you will have to use more than one thing. So it won't be only sum of forces 0 or moments above 1.0. You will have to combine them and probably have simultaneous equations. So this is not unlikely that for one question, mainly when it's so many marks, you will have to combine more than one thing. Yeah, and this is all with this question. Hello, if you liked the video, I have a free last-minute revision course the week before your exams. The link is in the description below. I'm working with international levels for Edexcel, but if you are an UK student, you will find this very helpful as well because the questions are identical, you just have less topics. I have other courses through the year, they are all in my website and the link is as well in the description below. I would love to help you.